So to begin with, we started off of parallel circuit 1 here. We solved for this, R2 and 3, and now we're going to parallel circuit 2. So what we're going to solve for is R5 and 6. So we're going to have to figure out what that's equal to. So we're going to use the same formula right here. So that's going to be R5 times R6, since there's only two resistors in this parallel circuit. And then we're going to add those, R5 plus R6 together, and that's going to be equal to 600 times 900 divided by parentheses 600 plus 900. It's going to be equal to 360 ohms. 360 ohms. Alright, so now that we made this, we can make this into a series circuit. Or we can find RT. So this thing, the whole entire thing right here, are 5 and 6. We know it's no, not R5 and 6 is 2 and 3. R2 and 3.
Can you hear me, Anthony?
Yes, sir.
Okay, yeah. I was saying something about 360 on. What's the next thing? R2 or 3. Okay.
So we're gonna create into a series circuit now.
Right.
So you know that this resistance is 300 ohms for this whole entire thing.
Right.
This thing right here are
360. Yeah.
5
and 6.
and 6
Yes, sir.
is equal to 360 ohms right here.
Ohms. Right. 360 ohms. So now it's a full series.
Yes, sir. So we're gonna add
That's the only thing. I thought it would have.
That's gonna solve for one of our equations, RT, right here. RT is going to equal to R1 plus R2 plus R3 plus R4 plus R5. Oh no. Oops. R2 and 3 since they're parallel plus R4 plus R5 and 6 plus R7.
Right.
And that's going to equal to, let's see. Let's do it real quick.
1200.
Sir. So it's going to be 1,200 ohms or
Right.
1.2 kilo ohms. And to write that, doing words, you can just go here, symbol, ohms. 1.2 kilo ohms right there.
Right. Well, that's crazy. Okay.
All right.
1.2K.
Now that we have this, we can solve for total current. So IT is going to equal to ET divided by RT. So IT is going to equal to 120 volts divided by 1.2 kilo ohms.
Yeah, but you wouldn't do it, and you got to put it in the base like she said, 1200. It just be 1200, right?
Yeah, you could. You just put this if you want.
Yeah.
So it's 120 divided by
1200 because it looks a little bit easier though.
Yep, and that's going to equal to 1.1 amp.
0.1 amp.
Yep, 0.
Right, I have that. So like you said, I have all that right. I had our ETs. I have the total, the volt total, the current total, and the resistance total, and the power total, right? But nothing else. So how do we get to the rest. Let me see. Resistor total 1200 ohms.
So to get that, we're going to look at it as a series circuit now, for now, okay?
Yes, sir.
So we know that going through the circuit, throughout the circuit, we're going to have 0.1 amps if it's a series. So 0.1 amps is constant throughout the whole entire circuit. So
So
0.1 amps here.
the current is
Huh? Hello? You're cutting out.
yeah. Yours going out too. You going on in and out too. So the current
Oh,
is 0.1 amp for every other current is 0.1.
so it's 0.1 for every series in the circuit. So if you see it branching out right here in the parallel, these are going to have their
Right.
own separate current, okay? So
So
once
those
they
two
go
gonna have
back together, right?
okay. Okay,
So
so they're gonna equal up to 0.1 amp or something like that.
so this whole entire circuit in a series is going to have 0.1 amp. So both of these currents, I2 and I3, are going to equal to
0.55.
0.1 amps whenever they combine together. So when you add them together, they're going to equal to 0.1 amps. That's where you went wrong in your equation. So right here, since we have this and this and this, we can solve for E1. E1 is going to equal to 0.1 amps times 150 ohms. I'm just going to copy this. And that's going to equal to 15 volts. Alright? So E2 and 3 is going to equal to 300, no, not 300, 0.1 amps times 300 ohms. You see this? The total is 300 ohms for R2 and 3. So since it's in a series right here, we're going to calculate for the total energy or total voltage inside the whole entire circuit. So 0.1 times 300 is going to equal to 30 volts. So you know that E2 and E3 both are 30 volts. Because in a parallel circuit, energy right here are equal to each other. Now we can solve
Your
for current.
screen is going in and out. It's like I can barely hear you. It's going in and out.
Oh, hold up. Let me rejoin then. Hello? 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 Are you there? Hello?
Hello?
Hello? You're good?
Okay, yeah, I hear you.
Alright. So let's go ahead and go back. So you know how I got here, right? E2 and 3 is equal to 30 volts. Because I look at it as a series circuit. You can still hear me, right? Hello? Well, I'm just going to continue, okay? So, once you get this, you can solve for current. on each one of them. So I2 is going to equal to E2 divided by R2. E2 divided by R2 is 30 divided by 500. And that's going to equal to 0.06 amps. So this is voltage and this is ohms.
Okay.
So that's how you get I2. Next thing we're gonna solve for. Here, I'm just gonna fill in what I've solved already. So this is 15 volts. I2 is 0.06 amps. I3, let's go to I3. I3 is equal to 30 volts divided by 750 ohms. Because we're going to use the same equation right here.
Mm-hmm.
So E3 divided by R3 is going to equal to that. And that is going to equal to 0.04 amps. And if you want to double check, I2 plus I3 should equal to 0.1 amp. And as you can see, 0.06 amps plus 0.04 amps is equal to 0.1 amp. So that makes sense, right?
E1, E.
Huh?
Hello?
Yeah.
Oh, so yeah. So 0.4, yeah. 0.4, I2. What you got divided by I3?
So right here, I3
Yes, sir.
is equal to energy 3 divided by resistance 3. So that's going to give you your current. So that's 30
volts.
volts divided by
Okay.
750 ohms, okay?
Right.
So now we solve for that. We solve for the whole entire parallel circuit right here. We're going to move on to this circuit. So what's missing now is E4. And that's equal to I4 times R4. So current 4 and resistance 4. And that's going to equal to 0.1 amps times 140 ohms. And that's going to equal to 14 volts. So as you can see here, this is 14 volts. And now we're going to move on to this. We're going to look at this as a series circuit again. Let's go ahead and move on.
E3.
So we know that
E1 equals 15 volts.
I5 and 6 is equal to 0.1 amps, right? And then R5 and 6 is equal to 360 ohms. Given that, we can solve for total energy.
Volts.
Yep. E5 and 6, which will be the same, is going to equal to 1 amps times 360 ohm. And that's going to equal to 36 volts. And to get,
Okay. Hold on. Okay, I kind of see where it's going. Okay.
all right, and let's see. To get that, all I did was plug these two together. Current of I5 and 6, which equals to 0.1 amps divided by I mean, it times it by 360 ohms. Whoops. I did it wrong. Times R5, 6. And that's going to look like this. Current times resistance. Current times resistance. So it's going to give you 36 volts throughout this whole entire parallel circuit. So it's 36 there, and whoops, I messed up. It's going to be 36 here too. So now we got that, we can solve for the current inside the parallel circuit. So I5 is equal to 36 volts divided by 600 ohms. So it's going to be E5 divided by R5 right here. And that's going to equal to 600.06 amps. Next one is I6. And that's going to equal to E6 divided by R6. And that's going to equal to 36 volts divided by
5
100
divided by
ohms.
R5
And that's going to equal to
minus 36 volts. Am I looking at that right? E5 equal I5 equals E5 divided by R5 minus 36 volts. No, that's
No,
equal
equals to.
36 volts. Okay, equal 36 volts divided by 600 volts.
Mm-hmm.
Okay,
So
you get that
I5 is going to be 0.06 here.
I5 equals E5
And this is
divided
going
by
to be equal to
R5
0.04
36 volts
amps.
divided by 600 ohms equals 0.06 amps. And then I6 equals E6 divided by R6 equals 36 volts divided by 900 ohms. Yeah, 900 ohms
Yep.
equals 0.40. Okay, so for some reason, okay, I got you. 0.4 amps equals total, they equal 0.1 amp. Okay, I got you.
Yes, sir. So I5 plus I6. I5 plus I6 should equal to 1 amps.
So E23 and equals 0.1. Okay, so I'm behind. I need to go back up to the E23 again. E23. Got 1 amp times 300. Okay, I2. Yeah, hold on. Let me write that down right quick. I2 equals E2 divided by R2 equals what was that? 30 volts instead of 36 volts? 30 volts.
So you got confused on E23, right? How I got it?
Nah, I'm looking at it, yeah. 30 volts. Yeah, you got 0.1 amp times the 300 ohms equal 30 volts. I see that up there.
Yeah.
But I forgot, I didn't write that down as I was writing it because I couldn't understand it. I kind of understand it a little bit. Okay, so
R23.
okay, I2 equals E2 divided by R2 equals 30 volts divided by 500 ohms equals 0.6 amps again. And then what was the other one? I3 equals E3 divided by R3 equals 30 volts divided by 750 ohms. Yeah, 750 ohms equals 0.0 amps. Okay, I'm ready.
All right.
Okay.
So the last one, E7. E7 is going to equal to I7 times R7. And that's going to equal to 0.1 amps times 250 ohms. And that's going to equal to 0.1 times 250. It's going to be 25.
0. All the other ones equal 0.1 amps except 2 and 3 and 5 and 6. They have different amperage.
2 and 3 and 5 and 6, yeah.
So every other one at 0.1 amps. I got you.
Yeah,
Okay.
they're different. So
Yes, sir.
when you look at parallel circuits right here inside a series, you
Parallel
should look at
circuits.
it as a series
Right.
first. So we're gonna
Right.
look at this. We're gonna calculate the total
So break them down. I
ohms,
got you.
and then we're gonna look at what the current is for the total system. Since it's in a series circuit, the current should remain the same. So we can calculate for the voltage going through the whole entire system in this parallel. So once you calculate for the voltage, you only have one unknown. You have two knowns, so you can calculate for that one unknown. Now that we've finished it, you have any questions?
Yes, sir. It's E2 30 volts and E3 30 volts? Or
Yes,
are they
sir.
15? Are they 15?
It's 30
E2
volts.
is 15 and E3 is 15. Is it like that?
Yep, so E2 is 30 volts, E3 is 30 volts, E5 is 36 volts, E6 is 36 volts. So when you see it in a parallel, whatever
voltage is gonna
total
stay the
volts,
same?
huh?
Yeah, votes stay the same. Okay, votes stay the same. Yes, sir. In parallel,
Yep.
votes are the same. Okay.
So
Okay.
once you calculate for the total volts, no matter which direction it goes, this or that is going to remain the same.
Sir, and so all the voltage will total up to 120. Is also that's how that works?
Yes, sir.
Yeah,
So
I got you. So
you can double check that.
okay,
E1 plus
I messed up. Yeah.
E2 and 3 plus E4 plus
Okay.
E5 and 6
Right.
plus E7 is going to equal to 120 volt.
I got you.
So 15
Man. Okay.
plus
So
30.
I messed up on the current. Well, if I would have got that current, if I forgot that all the current in the parallel, was that parallel? All the current was 0.1 amperage. That's where I messed up at. And then I would have been able to figure out what those voltages were because I kept, so I got to go back and I got some other things I need to clean up. But
Yes,
thanks,
sir.
man. I appreciate that.
Of course.
I messed up right there. So dang. So yeah, it's the amperage. I forgot that in the parallel, the amperage stays the same.
No, not the amperage, it's the voltage. The amperage are different. So it's going to divide itself depending on the resistance here. So what you need to calculate first is just the voltage, and then you can solve for amperage. Because the
Right.
voltage is the same throughout the whole entire system once you solve for that. In a parallel.
So, oh,
Yes, sir. So
So-
that's why we solve for the total resistance first, and then we solve for the total amperage right here. So then once you put it in series, you can solve for the total amperage. So, I mean, we already solved for the total amperage, 0.1 amps, so then we can solve for the voltage. Since we have the total resistance here and the total amperage right here, we can solve for the total voltage for 2 and 3.
yeah.
Yep,
I
it's
just-
right here.
Dang, that kind of threw me off a little bit. I gotta remember that, man. This is where it's getting a little bit complex.
No problem. We'll all start somewhere. Hopefully you got that. So Let's backtrack. All right. So we look at it as a series first. You create this into a series circuit. 2 and 3. Turn it to a series. Solve for resistance, current, energy first, and then you can look at it as a parallel. And then you move on. It connects back to a series. You can solve this as a simple series right here. And then you come back here, you see a parallel. You turn it into a series. You solve for the total resistance, amperage, and voltage for this as a series only. And then you look at it as a parallel. So you got the voltage already since you solve for it. And voltage is the same throughout this system.
Right.
And then you can solve for current once you plugged it in. Since they gave you the resistance or resistor already, 600 ohms and 900 ohms. So you can see, you can calculate for how much current is going through each of these branches right here. And then once they connect together, they're back into a series circuit. And then you just solve for the last one, and then it should equal, everything should come back to this. Total resistance should be the same. Total, what's this? Total current.
Gotcha.
And total voltage. As you can tell that we solve for it too, at the very end.
Okay.
So 120 volts. That's how you calculate it. If you want to know if you did it right, all the volts should equal up to 120 since it's in the series.
Yes, sir.
Total amperage should remain the same no matter what in the series. And total resistance, you just add up everything. So this R3 and 2, R5 and 6, so you add that as a series. So 150, 300, 140, 360, and 250 should add up to 1,200.
Gotcha.
Yes, sir.
Man, I appreciate that so much, man. It's looking like you're a genius at this point, man. You really feel it. You fully understand it, man. I got, this is like a little it's starting to get complex.
No problem.
Thanks a lot, man.
Of course.
Oh man, so but be looking for me to give you a call somewhere in the future if I get stumped again, man. I just appreciate everything you've done for us, giving me, dropping whatever you're doing to assist me and help me, man. Thanks a lot.
Of course, no problem. Anytime.
Yeah, man.